Hey everyone, today I'm going to do a video on a facade again. This one is another example facade. I apologize for not making videos. I've been finishing up my architecture finals classes, and now that I'm done with all my classes, I'm going to start making some more videos and actually starting to do. I have a list of facades or precedents that I want to do, and I'm going to try to go over all of them. Some of them are pretty complicated, I haven't even tried yet. I just thought they looked cool, so I want to try them. So yeah, let's get to it. So this is the facade we're going to do today. It's pretty simple, but the script is somewhat complicated. It's a kind of a diamond-shaped facade. It's located in San Juan, Puerto Rico. It's a Brisolei facade. If you Google it, so we do Brisolei. If we look up a definition of Brisolei, it is a architectural feature of a building that reduces heat gain within the building by deflecting sunlight. So that's what this facade that's what this is here to do. So we are going to make it. Again, I just kind of took this off my phone. I usually, when I pick something, I pick it because I'm like, oh, that looks interesting, I want to try that out. And then I screenshot it and save it into an album of videos I want to do. So yeah, that's for that. Okay. So let's get on to the Rhino part. So just open up Rhino. I'm going to work in top view for most of this. There are some parts where I'm going to work in perspective view, but it's mostly top view. Just because it's easy. So usually I like to work in top view. It makes things a little easier for me. So, because usually most of the defaults for Grasshopper is set in the XY plane, so it just makes it easier. So we're going to start with if we look at it, I already deleted it, sorry. If we remember, we had those diamond shaped. So your first instinct is to probably make that diamond shape using something else like Lunchbox or any other program. But the problem with that is it doesn't actually start to there's a listing issue when you start to actually try to manipulate that geometry. Lunchbox is good for if you just want straight panelization or straight something else, just that form. But it's not good for manipulating afterwards if you want to actually start to mess around with the geometry. That's just my opinion. I haven't messed around with Lunchbox that much, so maybe I am wrong, and I'm going to look into that more. Further down the line, I'm going to learn Lunchbox pretty extensively and other programs such as Diva and a new one that I saw called Salamander. It's for structure, so I'm going to look that up. Or I have it. I'm going to try learning it. They have a tutorial out now. It's on beta tests or some version of that. So anyways, enough with my rant. Let's get on to it. So we're going to start actually with the polygon. So we're going to start off with the basic shape of a polygon. When we have this polygon, we're going to now set the sides to 3. And the reason why we're doing 3 is because if we know what a diamond shaped is, oh, wrong place. If we know what a diamond shaped is basically this plus mirrored. So we're going to actually do that, but mirror it. and we're gonna try to make the diamond shape into one whole shape, into one kind of cohesive shape. Also for reference, every time I do a video, I've done the script already beforehand just to understand how it is, so I don't just talk indefinitely. But if you guys would like a video of me just talking, or just me talking and understanding the script and actually my thought process, or like going cold turkey in a sense into a script, I can do that. I just think you guys would like me to start to talk about because I've already done this Brisolei script already, but I like to do it again and explain to you guys so you guys can understand my thought process behind it and all that stuff. But if you guys want me to actually just kind of go cold turkey into a facade and see my thought process, I'll be happy to do that. Doesn't mean I'll get it right. So, anyways, sorry. This is a lot on my mind. I haven't made a video in a while, so anyways, so we have the triangle here. But the problem is the triangle is rotated weird, so I want it rotated another way. So I'm going to actually put a radius onto here, so I'm going to keep it at 2. That's pretty small. That's good. So what we're going to do is actually rotate the geometry back to, we're probably going to rotate it 90 degrees, so it's, the tip is facing this way. So all we do is radians, and 90. Plug this in here, and geometry. And we can turn this off. And there's a gridding on here, so that's why you can't see that one. So yeah, that's just that part. So we have that triangle. Cool. So what we're gonna do is we're gonna do an explode real quick, because we want to rotate it. We want to mirror it along a curve. But if you do a mirror curve command, it asks for the curve to mirror it across. So we need this curve. So the way to do that is to take the curve and explode it, and it asks for segments and vertices. So we're going to do a list item and find that curve. So so that's that curve. 1, 2, 0, 1, 2. So it should be 2, I think. Maybe. Nope, sorry, this is 1. So let's just change it. So yeah, the list is now 1. So this is list 1 right here. So we have that one right here. We exploded that geometry. So what we did basically so far is we made the polygon shape. We rotated it to be kind of upright in a sense, and exploded the geometry to get the individual segments and vertices, and then we took what we needed, which was just this vertice. So now that we have that, we can now plug in the curve in here, and then geometry. And now you see it's mirrored. Awesome, that's what we needed. But we're also going to explode this one again. And what we're going to do now, we're going to explode the geometry and actually kind of capture these points. So this one, this one, this one, and this one. And this one again. So we can create the diamond shape. Because right now they're reading as 2 separate geometries, as you can see. They're reading 2 separately. So we're going to actually start to create the geometry to where it becomes one solid, and by using the polyline command. So the way to do that is we're going to list item each one of these points. So for here, all I did was list item 1. So let's list item the other 2 sides. So list item, and this one will be 0. And I'll type in a 2 for the next one. List item, segments, and 2. I'm going to put this in order. So 0, 1, 2. And you can also click this button right here to straighten this out. Apparently it's called Mr. Sparkle, but okay, I didn't know that. And yeah, cool. It just keeps the script somewhat neat. So we have this, and then those are for the segments, so we need to do it for the vertices as well. So that one I'm going to group. So let me just move this here. Do another list item, because remember, I just want to capture these lines just for reference, just in case we need them. I like to reference everything, and then if I need them, I can pull from them instead of redoing it and doing it under some giant scripts. Sorry about that. So what I like to do is now we can do the same thing. We can just do list and C, Control C, and then just paste it 3 times. I usually don't recommend copying and pasting, but if you know enough Grasshopper, if you're familiar with Grasshopper enough, it's fine to, it's fine to copy and paste, but sparingly, in my opinion. So yeah, we're going to keep the same numbers, so we're just going to borrow these 1 and 2. So now we have these lists, 1, 2, 3. So 0, 1, 2. Alright, cool. And then we're going to do the same thing for here. Do a list item, and I'm going to plug this in, and C, 3. So we now have 3. And then we're going to borrow the same numbers, because these numbers aren't going to change, so that's why I'm using the same exact ones. Now you can have separate sliders for each one of these, but I didn't see a point in it, so cool. Now we have those points. We're going to now do a weave command, but we're going to kind of understand how this works before we start any further. So we're going to start with this curve right here, so let's find that real quick. So this one, we're going to try to weave it like this. Okay, so let's do that. And I'm actually going to turn off these curves because they are not needed. And goodbye exploded geometry. I just want the points. We can turn this list item off as well. So we just want the points right now, because if we're trying to learn this right now, I know what to do, but if you guys are just trying to learn how to do this script in particular, this script, by the way, the script is not for beginners, but I will explain it as thoroughly as I can. So I just want to isolate everything to where you only see the things that you need, which is these points. So we're going to weave it like this. So this is going to be our base point. So this one, this one, this one, and this one, and this one. Alright, cool. Let's try that out. So we're going to do a weave. Alright. This pattern is going to be very important, but we'll talk about that later. So we're going to start plugging stuff in. And if you go to weave, and you're like, if you're looking at it, there's 4 points that we need to plug in, but there's only 2 streams to plug in. So we're like, okay, how are we going to do that? So if you zoom in, you can actually add streams. So we're going to add 4. So sweet, we added 4. So let's start putting those points in. So this one is 1, or 0. 1, 2, where's 3? 3. Cool, now it's weaving them all together, but the problem is, if we go to a panel and slap a panel on here, it's only reading 0 and 1. And you're like, why is it doing that? I plugged in 4. It doesn't make any sense. Why am I doing this? And you're like, why is it doing it? But if we look at the pattern, the weave pattern of input indices, I think that's how you say it, 2 locally defined values. It's defaulted to always have 2 locally defined values of 0 and 1. Remember, we added 2 and 3 here. So the problem is now it only recognizes 0 and 1. You're basically saying in the pattern, ignore 2 and 3, but only do 0 and 1. So let's say if we do a polyline, for example, all we're going to get is just a line, which doesn't help us. So what to do? What are you going to do, right? So what we're going to do is make a panel and double click it. Sorry about that, guys. So we're going to do the same thing here. So pattern is basically saying, what order do you want it to weave in? That's basically what the pattern is saying. So I want it to weave in the pattern I just said it, 0, 1, 2, 3. So 0, 1, 2, 3. And then click off, and let's say you plug this in, and it's turning red. You're like, what's going on? Nothing, it doesn't make sense. I just plugged in the pattern. It just asked for it. Just click, right click, and then uncheck the multi-line data, and then it'll work. So now you can see it's starting to read those points now. So now let's do a polyline to see if it works. Maybe I still messed up somewhere. Let's try it. This is closed. Sometimes this works. So 0, 1 is true and 0 is false. So there's nothing plugged in. So it's saying it's false. Let's try plugging it in. Okay. So it closes the polyline. Nice. So basically, when you do a polyline, it repeats the command. It repeats the last point, which is 0, in order to plug that in. It's just reading one polyline curve. Alright, cool. So, what we did basically is we weaved all these points together, and then we did a polyline in order to create the curvature, and then put a 1 in for a true-false statement. And the reason it's defaulted to false, so 0, and if we, because 1 is 0 and true is false, if you watched my list manipulation video, you would understand that 1 is 0 and true, or 1 is true and 0 is false. As you can see, 0 false, true. So cool. So now we have the polyline. Cool. Now we have that diamond shape, right? That's exactly what we needed. All right. Once we have that polyline, we're going to start to actually kind of manipulate the geometry by doing a move series in order to get that kind of gridding of points that they had. So let's start with that. Let's try doing that. Let's look at what they have right now. So what I'm going to do is I want to move it. I want to see how it moves it. So I'm going to do a move command, because I don't remember exactly how it moves. I don't remember everything I did for my script, so it's a little bit of an adventure as well. So we want to move it in this direction, so the X direction. But you want it to touch from this tip to this tip as well. So you want this end to touch this end when moving. So we do that, and then we can see it's moving from the center, I assume. Oh, also the reason why we did a polyline is if you just, now you're thinking, or here's what you're thinking. What happens, you're like, hey, this is way more complicated than it should be. You could have just taken these 2 segments from your list item and these two segments from your other list item right here in these segments, and just join the lines. Grasshopper doesn't read that as one closed surface, so or closed kind of line geometry. So when you try to do a area command, it doesn't work. I think maybe polygon center would work, but I have not tried that. So the way I went around doing this was to do it by polyline, so the area command would work. So now we have the center. So we want to move it. So I think it's moving from the center point onward. So knowing that, I'm going to try to find the distance between this point and this point. Now, yes, I could bake it and then do distance and then type in that same number, but we're going to do this parametrically. So what we're going to do is, we know the area point, and we're going to find this point. So if we remember, it's 0, 1, 2, so it should be 2 stream, which is here. All right, cool. So we're going to actually do a distance command. We've seen this distance command before in one of the attractor point lessons, I presume. So just plug this one in, and then plug this one in, and it will give us the distance, which is 1.73, I guess. Not too sure. That's just a number, and then plug this in here. So it's not moving from center to center. I think it's moving from point to point. So I was wrong. So let's do another distance. And I think it's moving from this point to this point, end to end. So we can just plug in that point, and oopsie, and this point. You could also do this point as well, so we could just use this one if we want the sake of clarity. Or, oopsie. Sorry, instead of this one, you could use this one. So this versus this. Yes. Alright, cool. So we also get 3.4. It should be, honestly, this distance should honestly be double, so we can actually do a test real quick. But the reason why I'm not going to keep it the multiplication in there, I want to keep it with this distance just to keep the script a little bit clean, instead of doing all this math for no reason when we have the geometry. You do the math when it's necessary, but we have the proper geometry in order to actually do the script, so, or to make it easier and make the script more understandable. So, or we could just plug it in right now. But if you want to test it out, you could do multiplication. So yeah, it's moving from end to end. Yeah, and I'll show you the multiplication route too as well, just in case you guys already did type it in. So we have the multiplication. This distance should be, because we did this, so it should literally be double. So we're going to type in 2 because we're doing multiplication, so it's going to be this number times 2. The distance times 2, and they literally should stay the same. Yep, cool. So this is another way of doing it. I like to keep all my stuff until the very end, unless it's legitimately like unnecessary. But I like to keep everything, especially when I'm teaching. I usually keep everything. So this, but you see the amount of scripting that's needed. This is 1, 2, 3, 4 components versus just this one component. It just makes the script cleaner, if you understand that. So we did a move, and we just did an X. So we only moved it once, but I want to move it in a series like we did in lesson 1 or lesson 2. So let's do that real quick. So let's do a series component. And this is the start, step, and counter. So you're basically asking yourself, where do I put this distance component? And you're thinking, okay, since we're just doing it by distance, it should be the step, which you would be correct. So let's just put it in the step, and then put that into series. And right now the default count is 10, so let's set the number to something we want. I'm going to do 12, so we can manipulate the geometry now, so I can start to add more and have less. So I'm going to put it at 20, or I'm going to put it at some lower number, 9, let's say. Actually, let's just put that at that even 10. 10 just makes things easier. Alright, cool. Now we have 10. Nice. So now I want to move it in the Y direction as well. So let's do that. So we have that grid field of these. But the problem is, there's a problem. If we think about it, if we move this point up here, it's just going to create that empty diamond shape here. But we want the area of that empty diamond shape as well. We don't want to just exclude it from the list. So to do that, we're going to have to move this halfway here, and then move halfway, and then move it up to where it fits flush with that point. from this point, or this kind of tip fits flush with this. So let's do that. So we're going to do an X direction again, and then we're going to move all the geometry to the X direction. And we're going to actually move it. Since we already have that component here, we're just going to plug it in. It's that distance component, like I said. In fact, I'm going to delete this just for the sake of this tutorial. Usually I'd keep it, but for the sake of this tutorial, I'm going to put it. Oh, didn't plug in, I guess. Come on. Alright, cool. So it's now in the center, and all I need to do is now move it from this distance to this distance. And we do have that distance, this area to here. So let's find the area. Here to here. So what's that point? 1, 2, 3, 4. So maybe 3, or 0, 1, 2, 3. So 3 right here. Alright, cool. Centroid. So now we get the distance between these two. Okay. Cool. Sorry. Not plugging in there. Let's do another move. And I like to turn this one off because this one's technically just kind of scrap work in a sense. Move it in the Y direction. And move this geometry. And we're going to plug in this distance into here. And now you see as it fits flush, but we have this kind of leftover lag here. As you can see, we just have this little tiny piece. So what we can do is actually just take call index. Actually, I'm going to do usually I do a list item first to figure out which one I want to call or nullify. So right now it's just nullifying this one probably. Yep. 0. If you type in 0, you get a number side that'll always go to 100. So I like to type in 0 if I'm going to do more than just like up to 10. So how many shapes are there? So it should be the last one. Technically we could just panel it. Let's see. Actually, probably it's number 9, right? I'm gonna. Doesn't hurt to double check your script though. 9. Yep, it's that last one. So call pattern 9. There we go. I like to keep the panels here too. As you can see, I always keep my panels. Panels are really nice to keep around just if you want reference information. So now we have that. I think the problem here though is I think this is grafted already. Oh no, it's not. All right, we're good. I was making sure it wasn't grafted because when you do a list item, usually it's grafted. So let me. Usually it's grafted if you get a bunch of things in a list. So we have that. We can hide this. So now we have this. So now we want to move this geometry and this geometry at the same time. So we're going to do a move. And we're going to do the motion Y. And then we're going to move it from this point to this point. So this whole entire thing. So it's, let's look back at our weave. I've been using the weave in order to kind of find the points easier. So, and we know that we did it in this pattern, so I don't have to guess each time and kind of click each one to figure out. Technically, there's not that many points, so it's fine. But if there were a lot of points, this weave would be your guideline. So we did 0, 1, 2, 3. So 1, 1, and 3. So whatever plugged into 1, 1, and 3 here. Okay, so let's do a distance again. 1, 0, sorry, 0, 1. Are you sure that's 1? What the hell? 1. Oh no, it's this one. So this one and 3. So this one. Oh, no. What the hell? Okay, this one. Alright. Cool. Alright, so now we have this distance right here. Well, now let's just plug this into here. We can plug the motion into here. We know move in the factor of Y, and we want to move this geometry. Alright, that seems to be working. But let's also plug in this one. Just hold down Shift. All I do is hold Shift. As you can see, when I let go of Shift, there's no plus symbol. Shift, there is. And there we go. Nice. Now that's just if we want to move it one more time. But I want to move it way more than one more time. Let me see the geometry is working. Yep, okay, it should be fine. Alright. So let's move it more times than that. So let's do a series component again. Series component, step here, and then count will be 10. And then we're going to have to graft, graft these two. So let's plug them both in here, or plug graft. Technically I could just, no, I don't want to do that. Graft, 1, 2, cool. So now we have a giant wall of stuff. So now it's looking a lot more like it. This is looking a lot better. It definitely has some, now we're getting that wall. Now, so it took all this script just to make that wall. And as you see, I like to spread out, so I apologize for that if you don't like that, but that's just the way I script. So we got the wall. We pretty much have that wall. All we need to do now is just give it a thickness. Give it a thickness here, and give it kind of a thickness, and then add a circle. So that should be easy, right? So we're gonna do another area command. Plug in the geometry, and then just we see all these dots. So we're gonna create that circle. Circle. Plane will be that centroid, and then the radius will be 0.25. I think that's pretty small actually. So I'm going to zoom in on one of these circles. It doesn't matter which one. Then kind of play with the slider and see what I like. I want it bigger than that. I'm going to do, and then do a rational. Plug this in here. So all I did basically was just instead of change it to rounding numbers, so you'll get more of a precise way of getting that circle. So I'm gonna do that. No, that's nice. All right, I like that. That seems to take up a majority of it and kind of looks something like it. All right. Now that we have that, we also want to give the lines the thickness. So I'm going to do an offset curve. And we're going to offset this curve by, let's say, 1/4 of an inch right now. I like to just go pretty small and then go large if I have to. So I offsetted that curve, and now I'm getting this thickness. Amazing. That's exactly what I wanted. Okay, so now that we have that, we want to fill in these gaps right here to create that surface in order to give it some thickness. So let's do that. Let's actually start to do that. So if we do a boundary surface right now, we're just going to get solid. We're just going to get these insides, which we technically do need, but not right now. I'll show you that part later. We'll get to that. But we want, we want the, what's a good place to show it? Probably the end here. We want to fill in these areas right here. Right here. So the way to do that, and the way I'm going to do it, is we're going to do a region difference. So I can type it in sometimes. I usually don't like to do it. The way I learned it was to always go to like surface. Usually, me as a modeler, I'm a type person. Even when I model in Rhino, I'm a type person. But the way I learned it, I always learned it like, oh, click here or something. But we can just type it this time. So region difference. And this will subtract the difference between this giant line, or the area of this, where is it? The area of this surface versus the area of this surface. And it'll only leave us with that tiny sliver we want. Hope that made sense. Yeah, I just want to tell you guys how I am as a modeler. So that's just how I am, I guess. So that's the way I've learned, at least, always. I don't even think it's under surface. I think it's under intersection. Yeah, region difference. I learned it this way because I think someone in the Grasshopper 3D forums taught me like this. So, yeah. Okay, awesome. So we're going to take the big surface. Take the big surface, and then the little surface. And then I'll subtract the two. Cool. And now let's do the boundary surface. And then we should run into a problem. This is a guarantee. We should run into a problem. Yeah. So it only works for one of them, or two of them. Actually, none of them. Actually, two of them. So see, as you see, it's working for one, but it's not working for the rest. You're like, what's going on? Did I mess up something? No. Now this is a listing issue, and I figured out the issue on this when I was making it myself. So let's go throw in some panels. That's the first step if you have a list issue. If something goes wrong, if you logically think about it and like, oh, that should do the boundary source, and it doesn't, it's almost 100% of the time a listing issue, or you didn't plug something in. And we can see that we have, if the way I do it is if you hover over these geometry, you can see how many is defined. So we have 190 locally defined values right now, and this now has also 190. So it's not like I'm adding more lines, right? If it was saying 190 locally defined values and let's say 230 locally defined values, then it would have to create more surfaces in order to offset the amount of to also fulfill the script of it having 230 locally defined. But since they both match 190, we're good. So let's look at the list, and we immediately see a problem. And you're asking, I don't see anything wrong. And if you do, then you know how to list. But anyways, you see this is listed to up to 10 right here. And this is not even listed at all. It's grafted except for these first 2 points, and it's going to throw off the script. And that's why only two of them worked. This one and this one. If you remember when we did plug in the boundary surface, only this one and I think this one worked. So let's do this real quick. The way to fix this issue is to do a partition list. We're going to partition it to look something like this. Exactly like 0 through 9, and it's going to work. I hope. Partition list. List size. So basically, what this list is saying the 10. So let's find that 10. Remember we did a series? That's what the series is being based off right now. It's being based off of that 10 number that we plugged in earlier. So let's just look back on our script. Where's series at? 10. So if we do 11, if it'll work. Sorry, it lags when you have so much geometry. Do 11. Let it load. Okay, we did 15. Okay, we're going big here. All right. Oh, it still says 10. Huh. Let me see. Oh, now we have this wall of hell. All right. Let's see. Oh, because I called it. Okay. Maybe we shouldn't call it then. Entices 9. Okay, shouldn't it be? Okay, so I had this at 10 and I subtracted the last one. So we're going to do a subtraction command. So the reason why I'm doing a subtraction is because remember we had this at 10 and now we're subtracting that kind of area right now because we we eliminated that area literally with the col index. So what we're going to do, sorry I keep moving it around, that's how I model. So what we're going to do is take this, since that was 9, we're going to subtract, and this was 10, it should be a subtraction by 1 kind of principle. So let's try that. 1. And plug that in. Okay, it's loading. I thought it crashed. Alright, cool. It works now. So it's now automated and parametric instead of it just being like I put it in for the one-time use. So now we can actually use this slider and it'll correspond with this one as well. And that's the beauty of parametrics, is that everything will correspond with each other. Or should. There we go. So we're going to do a partition list. Sorry, I got sidetracked because I had to make sure that worked. So as you can see, we still have our 9. Moved. Still have 9. Why are we having 9? Oh, this number. Maybe this is the number that changes it. Again, I do make mistakes in scripts. I'm not perfect, so if you guys say I messed up something, I probably did. So I'm not perfect, but I'm going through the process on how I do it, and I have done the script already, so I know how to do it. It's just sometimes I have to rework through it. So let's just change this number to, and if the number slider lags, what I like to do is double click and double click the numeric value and type in the number that you want. So I'm going to do, instead of saying 10, it should say 11 now. 0 through 11, which is technically 1 through 12, but they like to count 0 as a number. Okay, it's loading. Let it load. So it should bump some up. Okay, cool. So let's see the list. Alright, cool, it does say that. Alright, so that is the number that's corresponding with this list right here. Alright, awesome. And it should, I don't know why I didn't think about that, because I plugged the panel literally into here, so it should correspond with this, but whatever. Anyways, so we're going to start to partition this list, and we're going to do it in chunks of 12. But to automate it, we can plug in this number into the partition, so we always partition the same amount that we change. So if we wanted this to be 10 again, it'll be partitioned to 10. If we wanted this to be 12 again, then we can partition this to 12 again. So we're going to plug this in and just shove that in there. And this curve here, is it this one? Yes, it's this one. Alright, so watch when we partition this. So this is the before we modified it, and paneling, and after. Well, that didn't change much. Partition did not print. Abort. That's strange. Why didn't that partition work? Partition list. List as values. 348. Whoa. 348. Oh, this also 348. I forgot to change the number. So this list, or maybe I didn't partition it. I could have, because this should have worked, because when you partition it, it'll divide, or it'll shove everything. Oh, I know what I did. Okay. The way to partition things is to flatten the items first, because right now it's in this weird list. It's technically all grafted except for, like, what, 2? So as you can see, right now, if I flatten it, it should work. And now it's partitioning it to that amount. So basically all I did was, if you want to see it physically, what happened in terms of listing, we'll plug this in, and then we can do this. And then we can zoom in to what we got here. So right now, all we did was we changed this messed up kind of listing. I don't know what list this is and how they did it, or what the program says, but we have this, and then we're like, okay, let's flatten it all so we can reorganize it, right? So we're basically getting rid of all these branches and putting it under one, and then we're going to reorganize it to the way we want. So right now, they should correspond to each other. These two lists should correspond with each other. As you can see, they do. 0, 0, 1, 2, 3, 4, so 11, 11. Okay, cool. So they do. See, 11, 11, 0, 0. Awesome. So they do correspond with each other. That's what matters. Alright, now we have our region difference. Now let's try the boundary surface. Now let's see if it works. And this should lag a little bit. And it didn't work. Okay. Oh wait, I didn't plug in the partition in. Okay, I forgot to plug in the partition. And as you can see, oh, here's the example. So you see, I forgot to plug in the partition. But anyways, as you can see, it didn't. As you see, only this one and this one worked, and you can see it evidence in the list. Only this one, and where is it? This one worked. And I bet you if we did a list item, it would show those two are the only ones that are working. So, what's this one? It's connected into curve B. So this should work. Sorry, my computer's lagging a little bit, so let's see. So we have our boundary surface, but now it's all kind of patterned into a weird way where it only ignores like every other one. Just strange. That is really weird. Because all these lists should read the same. since they're reading the same, they should correspond with each other now. Unless, no, it still reads the same number. Yeah. Okay. That should have worked, but you know what? Things never work the first time, or the second time. Alright. So, I may have messed up. I probably did mess up. As you can see, I did mess up. But it's only skipping every other one. It's making this weird pattern. Maybe I have to, like... This looks like... Oh, it's creating 619. Holy shit. That is not right. Because right now it's just doing 619. That is not right. It's making 619. It should only be making the 348. So, let me look at this real quick. What in God's name is it making? What is this? 0, 1, 2, 3, 4, 5. What? I don't know what's doing here. Alright. I don't know what that was. We're going to try one more thing. We're going to flatten everything. Or we can graft it. I'm going to try grafting first. Grafting will create everything into to look something like this without the doubles. Just as everything in one separate branch. So let's try that. So they all read the same. Technically the partition should have worked in theory, but you know what? Things never work out with me. Oh, I should have deleted that edge surface, so it's going to freak out now. Alright, I'm going to delete the boundary surface. And now let's do B. Let's try that out now. Alright. Boundary surface. Is it working, or am I just getting illusioned? Okay, it is working. Alright, so maybe I did graft it, but this, in theory, should have worked because of the listing. Maybe the only thing I can think of that probably could have went wrong is that the zeros and zeros don't correspond with the same 0 and 0 here. Maybe this 0 and this 0 doesn't correspond with the same 0 here. That's also a thing that could have happened. I'm not too sure exactly what happened, but this is not needed anymore. But so we just basically went over list manipulation lesson all over again. So I'm just going to keep this to the side. If you guys obtain the script, you don't have to keep it, obviously. So sorry about that, guys. It took so long, but that's just the beauty in understanding how the script works and actually actually understanding the process on what it takes to make the script. As you can see, even though I already made the script once, I'm already making mistakes, and not mistakes, it's just kind of trial and error, iterations and seeing how that works out. So yes, it didn't work out the first time or the second time I did, but that's just the kind of beauty of Grasshopper and how you have to constantly work at it till it gives you what you want, and actually manipulating the script to the way you to where you can understand it and then manipulate it, because it's knowing it is literally 90% of the battle, and 10% is just finding the command for it. That's literally it. And sometimes the 10% sucks, but it's usually the 90% that sucks the worst. So a lesson here is just learning and understanding how script works, or understanding how the script works, and then applying a command or a node to it that can help you out and aid in the process of understanding the script that you made. So yeah, that's my 2 cents of the day. So yeah, this is the boundary surface. So now we made that boundary surface, and if we go into perspective view, we can see now it's that surface, and we can actually start to extrude that surface into an actual solid. So we're just going to do a Z extrusion, the Z axis to, as you can see, I always plug it in last because it always freaks out when I plug this in first. So I always do this and then plug in the base. Okay, cool. You can see now we're getting that, which is nice. Awesome. That's really sweet. So now we have this done. We have the fence done, or this part done. Now we're going to have to do the circles. We're going to have to cut out and make a surface. So what we're going to do is make that surface, extrude it, then cut out the circle to make the hole. to make that type of Brisolei facade. So let's do that boundary surface again. Remember in the last part I said we're going to come back to it, so we're coming back to it. I made that surface. We're going to extrude it. I'm going to extrude it probably only like half an inch. It doesn't need to be that big. In the Z direction. Sorry. I keep forgetting like Z isn't default on here when you extrude. So yeah, now we extruded it. Actually, yep, 0.5. And now we just need to find that circle. Where is it? So here's the circle. And we need to extrude the circle in the Z direction. And we have to make it, it is key to make this number, what's it called? Sorry. This number, or the extrusion number, has to be larger than this always. So the way I would do it, to always keep it, if you want to change the thickness of this thing without have to constantly changing this number slider and corresponding, the way to do it is doing it in addition and always doing a +1 to it. So 1 plus whatever you want it to be. It just has to be larger than this number. So I'm just going to plug in this into here, and Z, and circle, and now we have that. But right now it's not reading as solids, they're just reading as extruded kind of surfaces. So what we're going to have to do is do a cap holes and easily just kind of plug this up. Awesome. So we have that. We have this. So what we need to do now is actually start to, we can do now an equivalent. If you know how to use Rhino, you know what this is. We're going to do essentially a Boolean difference now. Rhino has their Boolean difference, and it's probably one of the most useful commands. So we're doing now a Boolean difference, basically in Grasshopper, and we're basically almost done now. So let's do it. It's not called Boolean difference. There's a Boolean toggle, but this doesn't do crap, so I don't know what it's for. So let's do, it's called a solid difference. And it's basically the same exact kind of parameters as a regular Boolean difference. Let me subtract from. So this is subtract from, and this is subtract with. And for the sake of this tutorial, I'm actually going to rename it just for you guys. So subtract from, and rename this subtract with. Awesome. So we're going to subtract from this surface and subtract with this solid. Sorry, subtract with that solid with that solid. So now we get that whole geometry, and we can actually hide this and hide the circle geometry and hide the extrusion. And it should make it. Let me see if it made it. Sometimes this doesn't work. Okay, it made it on these two. So we're having the same exact symptoms. If you remember back to what we just did with the boundary surface, we're having that exact same symptom where it's only working for those two, of course. But 348. All right, that's the first thing I like to check to make sure the numbers are the same. And now we're going to just do, the way I solved it here is to graft it, so let's just do the same thing. And in fact, we can just actually, instead of doing a graft and plugging this in here and then plugging that back in, Grasshopper does have shortcuts on the most common commands. So I do use reverse a lot, I do use flatten and graft a lot. I don't use simplify that often, but these three are the most useful in my opinion. So so we're going to do a graft here, and it's going to lag, and then a graft here. So it's just loading. So yeah, it's just loading right now. Okay, cool. And so basically, it says if you hover over graft, it's basically essentially is the exact same thing as this. Instead of doing this, we can do just a graft here. So instead of unplugging stuff constantly and all that stuff, you can just kind of, if you know it's just this command, you can just graft it. So awesome. Now we have we're done basically. So we just need to straighten that out. Group. What I like to do now, I'm going to organize it a little bit. All these distances are important, so I'm going to do that. Group. Put this together. So if I want more, this will be the, let me see. This is the number in the x direction, so it'll just be number in x direction. Okay. Let it load. For some reason, it takes a while to load the name of it. I don't know. Computers. Number in x direction. Cool. Oh, it's still loading because I don't know. There's no parameters that really change except for the name, but whatever. This one is the col index, so I like to keep that. And this is number in y direction. So let's do that. Number in y direction. And click OK. Let it load again. Sorry, my computer is not exactly the best, but it's definitely not the worst. I've seen worse. So, okay. And it is 1:29 a.m. Cool. Awesome. So we got this. Just organize this out a little bit. So we're just going to organize the script out a little bit. I like to keep things a little bit aligned, just to make sure everything is kind of together. So this is independent. This is just, what is that, 0.5 from? Oh, that's just the thickness. So we can say, we can name this thickness of bottom piece. Now you can group all your number sliders into one area if you want to have the parameters all in one area. I never do that, but if you're giving the script to someone else, that would be the most useful way to do it, is put all the most important number sliders into like right here, but I'm not doing that. So I'm going to do a group. As you see, the script is quite long for, well, it's pretty simple, but it's just long. That's pretty much it. Group this, and now save it on, and I'll just save it on desktop. No, we're going to save it into our YouTube folder, whatever that is. Kinetic architecture. We're going to name it Brisolei. I already have, let's see, Brisolei Facade. You can see Brisolei Facade B2. It's the same thing, but I'm just going to name it B2. So this is the circular geometry. So I'm just going to click that, whoop. And then this, if you want to go kind of crazy on labeling, double click, type in scribble, double click, and just do bake me. So if you want someone to know where to bake at, you can do it here. You can do it 70. In fact, this should be the biggest if you want someone to know where to bake it. So we can do it here too as well. We can do, well, we already labeled the number slider, but if you want extra text, you can. So this can be scribble. This can be circle geometry, and something like that. These can be points, so you can do scribble. Of diamond. And then kind of max that shit out into that. And these parameters are obvious. They're at the very beginning, so I'm not even going to label them. But yeah, that's pretty much it. I'm actually going to bake it now for you guys. So let's bake it. Bake. And I like to always group everything. So group. And then I like to bake this. So bake this, group yes. Awesome, so cool. So now we can save, close Grasshopper, and look at our work. And did it bake that circle shit? Oh no. And it did not. Okay. So let's go back into Grasshopper. It did not bake that circle stuff. No. Alright. So delete that. We'll bake again. Let's try again. Okay, there we go. I don't know what happened the first time. And now it's processing the geometry. And excuse my language for the video, but that's just real life. So yeah, now we have that. So you can see, now let's close Grasshopper. Now we have it. Cool. So now it's in shaded view. As you can see, it looks pretty realistic in the sense that it matches the precedent that we were trying to study. Now the only problem is that it's flat, and the easiest way is if you want to do this part parametrically, you can, but I see no point in it this time. Just rotate it. Turn ortho on. Rotate. And in fact, I can max screen this. Rotate this, and what I like to do is if you're gonna render this, do a plane here. And since these are grouped, you can just click both of them, and then do a move. Vertical, yes. Move them to this plane. Make it flush. Awesome. And now we're going to just kind of center this. So, oops, nope. Awesome. And now, once we have this, what I like to do, I don't like to keep it grouped forever. I like to put them in layers and then ungroup them so I can manipulate them if I need to. So I'm going to call this base surface, or interior, sorry. Interior circle. No. Where is rename? Interior circular thickness. I have some strange names, I guess. And then change object layer, so turn red. It doesn't, in rendered view, it doesn't actually turn red, but layer 2, I'm just going to change it already because I want it to. I never keep anything in the default layer because the default layer is for, I call this my, usually I rename it to buffer layer, but whatever. That's just how I do things. So let's rename this to framing. That's easy enough. And then I can just highlight both of these and ungroup. And now you have each individual geometry. If you don't want to ungroup, that's fine. So let's go actually in the render view just to see what this kind of looks like. So that looks really nice. Alright, before I go into rendered view, actually, let me set up a box. Let me set up a, what's it called? A light box. That's what it's called. So not really a light box, but just a bounding box in order to keep all the shading in, so we don't see kind of out here in the XY space. So we only see the model and then like 3 walls. So let's do that. So I'm going to do a dupe edge. So I'm going to select edge to dupe. And then I'm going to join them and extrude them. And then we're going to make, and then we're going to go in render view again. And now we have that box. So you can see. So now we only see those vertices and then just this. So if you want like a picture of it, that's what it kind of looked like. Render. Right. This is all I have right now is Rhino render. I don't have V-Ray on Rhino. I have V-Ray on 3ds Max. Now, if you guys want me to take it a step further, I can actually do a rendering portion section in 3ds Max and show you how to export it. But in this one, I'm just going to go to render settings and change kind of the DPI and all that crap. Yeah, just do viewport. I'm lazy. It's all gradient, ground plane settings, no sun. Well, yeah. Wait, we can do lights. We can add a light, so we can do a point light. Well, let's just add a, no sun. Render curves. So this is if you want to render, if you have like a geometry that's extremely complicated, you can render those. Let's just type OK. We're going to go and shade it again. And then we're going to add some lighting onto this box. So like kind of a point light. So what's it called? Spotlight. base of the cone, and I like to just kind of create a small lighting, kind of like this. So now it's ordered ortho. Move up and turn off ortho. Rotate downwards. Unclick. Now it's back to normal. The axes, and we kind of have our own lighting now. Well, we can rotate them one more. Now let's go back to rendered view. So you can see now there's some ambient light now. So now there are these circles, but I'm just trying to get the shadows. That's what's really like piques my interest. And in fact, do I really need this part of the surface? So let me explode this real quick and hide this so I can get a better angle. Oh no, come back. I like to never work in. I don't like working in rendered view. At least in this one. In Rhino 5 it was tolerable, but in this one it's not so much. So let's do like a person type of view. Human scale upwards. Alright, now let's try that. Render. I can make the edges of these lights fade, but I'm kind of lazy right now, so I'm just going to render it real quick. Right now it's just a 640 by 480. Nothing kind of fancy. This video is already an hour and 1 minute, but that's fine. All for the sake of learning. I'm all for that. So it's obviously a little bit grainy because I didn't really do anything to it, but we got that shadow and the rendering of it. So that's what's going to look like rendered. It's obviously going to look better if you play around with the settings, but that's just how this one is. It's just showing that facade. Awesome. So yeah, guys, that's... Oh, one more thing. Let me save this as a Rhino 5 file for you guys. I will put this up for you guys as well. So kinetic architecture and Brisolei. And I like to name my Rhino file the same as my Grasshopper file, or vice versa. My Grasshopper file the same as my Rhino file the same as my Grasshopper file, or Grasshopper file the same as my Rhino file. They need to be the same so you can understand which script goes with which. So V2 and click somewhere and then save. Nice, cool. So yeah, guys, that's pretty much it for this tutorial. It was a long one, just like my Al-Bahar responsive facade tutorial. But yeah, guys, that's pretty much it. Thank you guys for watching. Hope you guys have a great day.